Okay, so my name's Brian Chapados. I'm actually a scientist at Scripps and not Scripps Oceanography, Scripps Research. And so Ruby's actually just a hobby for me. And so periodically, I read about Ruby. And I think it was maybe about a year ago, I came across this article by Lucas Carlson on laptop security. And I think at the time he had just talked about buying a new G4 or something and wanted a way to protect the thing. And so he came up with this way to run a shell script in cron, right? That then looked at a website with wget, and if there was any kind of command in there, it would just execute that command as root. All right, so it's a pretty nasty hack, right? But it works. I mean, if somebody steals your laptop, you absolutely cannot count on being able to connect to it, because they're probably going to connect from some like private network or maybe just their home DSL or whatever. But you can't count on anything being open, right? So the idea of having a backdoor into your system is going to let you get through any kind of firewall, right? So you can't rely on incoming connections. You need to dial out, and you probably are going to have to use a reverse shell, right? Because I don't know, the way I think about it, I come from mostly a Unix background. So I mean, once you have a shell, it's sort of the end of the game. I mean, they're screwed, right? You can do anything you want, short of maybe get your laptop back. But there's things like geolocation and stuff. So apparently this has worked in some cases before, but I don't know. Anyway, so I saw this and I was playing with Amazon SQS anyway, right? Which is this queue service that Amazon does. Did I skip one? No. Okay. And it dawned on me that this would actually be maybe a pretty neat way to implement this. So I just started playing around for one day, and in like an hour or something, I came up with a couple of things that seemed to work, and I figured, oh yeah, this is cool. So then I sent out this email to the group saying I would give this talk, and I was hoping I would get some things refined, but it's still pretty rough. So I'm just going to present the basic overview of what I did, and it's kind of hackish, but there's some interesting things in here, I think. And so the idea is, instead of having to set up a web server and have this URL that you have to look at and execute some command, instead you can just use Amazon SQS queue, right? Because if you have a developer or if you have an account with Amazon, it's relatively secure. You have a couple ID numbers that are kind of hard to guess. And you can use that as sort of a way to build a secure backdoor into your system if you choose to. And so it turns out that you could do this without Ruby at all, but it's just that the Ruby gem for dealing with SQS is so nice that it's a few lines of code and you can access anything about the queue without ever having to know anything about either the SOAP or the REST-based interfaces. And so the idea of the whole thing is simple. It's basically two steps. I mean, you either have a way in cron or with Ruby or something to check this queue periodically in 5-10 minutes or whatever. And then if there's a message in that queue that contains a string or however you want to implement it, I just have it as a command string. It then executes that as root. And so it's dangerous, but I mean, you could use it to access any system you want that you feel like putting this thing on. And so just a quick overview of SQS. It actually is pretty feasible. There's more information on their website, but basically, like I said, it's a distributed text messaging system. You can create an unlimited number of queues. Everything has to be text-based, 256 kilobytes of message, 10 cents per 1,000 messages. That's pretty cheap. Probably not going to be using tons of messages. Has SOAP and REST APIs, and it does have a basic permission model, so you can actually give other people permission to read and write your queues. And so, so the point here is, like I said, once you have a shell, the game's over, but you can't connect normally, where you'd have a client connecting to a server because you can't count on the machine being accessible, so you have to go the other way, where the thing you'd normally think of as the client actually sends the shell out, but you can actually do that in Ruby or with some reverse telnet commands, and I'll show you the Ruby way because it's sort of interesting. Okay, so I started off with something I just called a beacon. Is this big enough? Anyway, so the idea is that we just have a beacon, and this include my SQS. I basically just wrapped all of my Amazon info into one place, right? So there's my key. So if you want to steal everything, you can just write those numbers down. Then I'll change them after this so that you can't do it. But for those watching on the web, don't even think about it. So anyway, this thing is just a wrapper that every time when you use the gem, right, you just have to tell it what your access keys are. Unfortunately, it doesn't have a way to use I think it's the X509 security certificate or something. That would actually probably be more convenient for this, because then you could just have that in a file somewhere. But anyway, for now you just give it your keys, and then these are just a few helper functions I have for like listing the queues and flushing them out and everything. But the gem's really easy to work with. I mean, essentially with this create queue command, you've created a queue, and you can delete them and rename them and things like that. And so then we just go back to beacon. So that includes that. We have an initialize who just makes a queue default name called beacon, and then this execute command essentially just does a receive message on the queue and gets the body and then just executes it. And I was having all kinds of problems with this, and I don't know why. It runs fine from the command line. I can't get it to work through cron, but I think it's because I have some like my root thing is not set up correctly, so I don't know. Anyway, I'm just going to demonstrate quickly the command line option. But let's see if there's anything else. The only other thing I wrote another quick little thing that I called open the backdoor, which will just like send a command into the queue that will then be executed. And then the final thing, this will work. This will let you run any command essentially. But then I thought, well, I wonder how hard it would be to actually just run the entire shell like through Ruby, right? Or through Amazon SQS. So like you basically have, this probably won't show up on the video, but like if the queue lives out here somewhere, you have two machines, home and server. They just always talk through this. So they're essentially like running a shell, but everything is the input and outputs all sent through Amazon SQS. I don't know, maybe it's dumb, but it would let you do all these things in a pinch, right, if you needed to. So the idea behind this is I just have this one class shell server. There's two functions that basically both just loop and just to create a shell. One of them just sleeps until it receives a message, and once it gets the message, it just executes the command and sends the output back, essentially. It's in here. Output message, sends the message, gets it back. The other one is actually an interactive shell, so this is the one where you are actually on the command line, you can type things in, and then it sends them through the queue, and it comes back out the other end. So hopefully this will actually work now. I just tested this. So the idea is, let's see, you'd have root on one end, so let's see if we can fire something into the queue. Maybe I already have it. Somewhere I have the command. I don't know what this is. Oh, I'm in a different shell. Alright. So this open backdoor is going to put this. So I should explain the situation. First we have, here this is my Mac, right? And here this is Parallels running Gentoo. Probably can't see either of these. It's the same thing? So, alright, so then if we put this command in, what it will do is just tell the backdoor to open up on the other machine, in principle. So we fire that off, wait for it to come back. This guy would normally be running cron, right? And then eventually at some point, as root, it would it would execute this beacon command, which would probably not be here, but would be somewhere more intelligent. All right. So then that should start. So then this would all be happening on the other system, right? So you'd have to send this out and wait for it to respond. Once you have that working, you should then be able to come in here and run, which one is it? Yeah, Q shell as the client, hopefully. All right. So then, first few I noticed are really slow actually, but if it works, we should get root on the other machine, yeah. And so then to prove that we're actually on Linux and not on Mac, yeah, it's pretty slow, but anyway, you can do all kinds of things, anything you'd normally want to do. I don't know, delete everything, RM minus RF star, I'm not going to do that, but you'll have to take my word for it that would work. I mean, you can, cat something on the end of that's the password or something. Whatever. It should all hopefully go through. But anyway, it's just a really basic demonstration of what you can do. I don't know, it's kind of fun. Mess around with this for a few hours and figure out what you can do. Amazon SQS is pretty cool, actually. I'm going to use it for something else that I'll probably talk about the real thing that I was doing with it, but maybe another time. So that's about all I have. Any questions, comments? Yeah, I meant to look that up, and I can't remember if it's sent plain text or not. Yeah, the other thought I had was if it is plain text, you could probably encrypt all your communication back and forth if you wanted to. But I didn't do that. My other thought, what I really wanted to do is get like a remote IRB session, actually, not a shell, because this is actually using forgot to mention this, but it's using the session gem from Era Howard. So he's got this way of wrapping up a shell in a session object, and essentially he does it by every time you execute a new command, it just creates a new shell and runs the command. So that it makes it really easy to do distributed shell commands on a different computer. But it's a little more tricky to do something like IRB. I mean, you could just execute Ruby commands, but then it's not the same thing as having an actual Ruby prompt where you could define functions and everything. Oh yeah, that's true. You could do that. Maybe that's the way to go. Anyway. Yeah. Oh, my thought was that ideally you'd want to have all Ruby because then it works on any platform. You can do any kind of admin stuff through Ruby. You're set. But anyway. Yeah, maybe that's a better way to go. I wasn't really totally familiar with all the options that were out there, but I learned a lot just playing around, so. Anything else? No? What was I going to use it for? I don't know. I would imagine that it's really good in situations where you want two machines to have to be able to communicate, but not necessarily know that much about the other machine. Like you just know. Like I was going to use it in my other example as a way to just coordinate running long running jobs on different remote computers because like I've had this web interface like hooked up to this thing. This query submission thing, and you can submit the job, but it takes like 2 or 3 minutes to run, like on my computer. So it's better to just fork it off somewhere else. And like, there's a number of systems like at work that we have that could run this thing, but they're not necessarily all connected in any kind of intelligent way. So I think that a really nice way to solve that is if they could just check at the queue periodically and just pull in a job and run it and then put something back, like just put the result back. It's really easy actually, and you can just dump the whole, like an object to YAML or something. stick it in the queue, the thing reads it back in, and that's it. You get the result back. I mean, that's how I was going to use it. I don't know what people are actually, I don't know all of the examples out there. Yeah, yeah, probably. I mean, there's other things too. There's like Rinda and all these other distributed object systems. So, but this is a little bit more generic than that. I mean, it's not really Ruby objects. It's just, yeah, it doesn't care. Just text. Right. That's the other thing you could use it for too. Yep. Yep. That's actually an issue at work that we have too. Like there's actually machines that we want to run things on that are fast, but that we don't really want exposed to the, right. So I mean, because I have like user accounts on like like supercomputer clusters and stuff, and I can set that up to just like run. Like it has outgoing access, but it's not accessible from the outside world. So yeah. Anyway, all right.
That concludes this episode of the SD.RB podcast. See you next time.